So in 8-7, we're skipping the first three and we're going to number 4 and asking ourselves, what's the better deal? 2 10-inch pizzas for $13 or 1 20-inch pizza for $21? Let's think of it like this. What shape is a pizza? You can say it. Circle. I'm down with it. There are square pizzas and rectangular pizzas. Are we cool with that? But how about we take it to like cylinder instead? Would you be cool with that? Because it does have thickness. Are you with me on that? So let's assume also that both pizzas have the same thickness. Like if one was pan crust and one was thin crust, you know, they're different thicknesses and all that stuff, but we're going to go the same thickness. So how do you feel that they are a circle, right? What does it mean that you have a 20-inch pizza? What's 20 inches? Like in the circle, what's 20 inches? Is it around it or across it? Across it, which would be what? The diameter. So how do you feel that the diameter of this is 20 and the diameter of this is 10, right? But there's 2 of those, right? And a lot of people think that that's the same deal. If you chose the deal that didn't make sense, it's normal. But I got something for you. If you're out there in video land, I'm going to pause because you won't be able to see this anyway in this case, but talk to me right here. When you talk about the dimensions of this guy is a radius. Are we cool with that? When I say dimensional, just like the dimension, it's got a radius. Question: does the radius go this way and this way? All right. So we got like twice as big this way and twice as big that way. Would you agree if we just pick on one pizza to the next, this pink pizza's radius is twice as big as this white pizza's radius, sorry, with a 2-to-1 ratio. But because if I was going to eat this pizza, would you believe I would eat the space inside of it, called the area, right? Isn't that the area of this guy? And last I checked, the area of a circle is pi r squared, correct? And if I double the radius, right, so if it went from like pi times 5 squared, which isn't that 25 pi, are you with me on that? And if I then doubled the radius to go pi r squared to 10, isn't that 100 pi? Isn't the bigger guy 4 times as much more? 100 pi is 4 times as much as 25 pi. And that's hard for the average human being who can even be pretty good at math. Right? You know, like the average people are like, whoa, I didn't see that coming at all, that's like 4 times as much pizza. And then when you put that second other pizza in there, now it's twice as much. Are you kind of with me on that? So it's like this is actually a much better deal, because if you paid for that twice, wouldn't you pay $26, right? You get 4 pizzas back, and here you only paid $21. And this is called mathematics and marketing, baby. It's like there's so many people that do not understand what is a better deal for them financially, and then the big companies know the math behind it, and they don't take advantage is the wrong phrase, you know, but they kind of like take advantage of some of the people in that case. So dimensional analysis is the idea today. We're going to ease our way into it with the next one. So you see I have pictures drawn for you on all this cool stuff. Here's our job today. What concept, what shape? If we can answer those 2 questions, we'll be in good shape. How does the volume, are you cool that we're talking volume, of a cube, are we cool that we're talking a cube, get affected if the sides are doubled? You see that I even drew it for us to save a little time. Like this guy's side length is 3, this guy's side length is 6. Are you cool that they're doubled? Let's do this the long way. We're going to crawl before we walk. There is a shortcut on the back side, but we've got to see the long way first. Let's find the volume of this cube. Go to your yellow card, find the formula for volume of a cube. What you got? Side cubed. And our side length is 3, so we just need to take 3 and cube it. So remember that means like raise it to the 3rd power. And it's not 9. That's what 3 times 3 is, bless you. How do you feel that it is 27 in that case? So the volume of this guy was 27 feet cubed. But what the heck's going to happen if you double all these side lengths? A lot of people would think, well, just double this and you get 54. Let's see if we get 54 back or not if we do this. Let's find the volume of this cube. So volume equals side cubed. And his side length is 6, right? So I'll let you punch that in this time. You can take 6 and cube it. And I think it's a little bit bigger number than 54. What did you get on that one? 216 cubic feet. Well, they ask how these compare. So what you do is take your big one divided by your small one, right? Take 216 and divide it by 27 and see how many times bigger is that. 216 divided by 27. How many times bigger is that other cube? 8 times bigger. So we'll write this answer. The volume got multiplied by, you see how I abbreviated multiplied by just mult. So multiplied by 8. And I'm going to try to ease us into understanding that. Hey, how do you feel that this got twice as big, but that got twice as big, and that got twice as big? Isn't there 3 different times something got twice as big? And last I checked, twice times twice times twice is 8. 2 times 2 times 2. So it's actually 8 times larger. So let's try that again. They say, how does the volume of a cylinder get affected if, just the height is tripled? So let's start by doing the long way of the work. Volume of a cylinder, pi r squared times h. Let's find that little guy right there. So the volume will be pi. What's the radius of this cylinder, baby? 3. And the height is 2. And then we'll punch that in. I think we can get the decimal. That's fine. We've been doing it that way all chapter. Might as well keep doing it there. So pi times 3 squared times 2. And like 56.5-ish. Does that sound okay? No, 50. Did I say 56.5? Is that what I said? Thank you. Units cubed. But notice this. They didn't change everything on this cylinder. They only changed the height. Are you with me? Isn't the radius still the same? Right? So let's see what happened to that guy. The volume is going to be pi r squared times height. And the radius is the same, so he's still going to be 3 squared. But the height has been tripled. The height has been tripled. So we'll punch that in and get a little decimal. Pi times 3 squared times 6, right? Basically 169.6-ish, right? And if I divide those, because we rounded off, it's not going to be perfect, 169.6-ish, right? But if I divide those, 169.6 divided by 56.5, I'm going to get really close to what actually happened. But if we would have kept it with the pi's, we'd get exactly. How many times bigger did it get? 3, right? You know, it's a little off because of the rounding now, but it got 3 times bigger, right? So it got multiplied by 3. But y'all, this is way too much work. There is an easier way to do it, right? Because here's what you got to do. I know there's one more problem after this, but look in the formulas, right? Check these formulas out. What got affected? This is dimensional analysis. What dimension got affected? There's a radius, there's a height. Those are the dimensions. Which dimension got affected? The height. You see that? The radius stayed the same. Are you with me on that? And what power is the height raised to? You see, like the radius is being squared. Are you with me on that? What power is the height being raised to? When you don't see a number there, there's a 1 there. Are we cool with that? So isn't it just to the first power? Are we okay with that? So if they're going to triple this, doesn't this also get tripled, right? So last one, I want to do a visual example instead of just do the math because I'm tired of doing the math, right? I'm a math guy. I don't want to do the math because there's a faster way. They say, how does the volume of a box get affected if its length is tripled and its height is doubled? Sorry, video people, you're not going to be able to see this. But it's weird, but watch this guy go into play on the backside. The shortcut of this is called the drop arrow system. And this is how you'll do your homework questions and your test questions today with the drop arrow system. Trust me, it works. It's weird at first. All you got to know is what concept and what shape. So how does the volume of a cylinder change if the radius is tripled? What concept? Volume. What shape? And then I guess you need one more thing. You need a formula. Can we write down the formula for volume of a cylinder? And we'll cheat it instead of the yellow card one where it says base area times height. Let's do pi r squared times height. Are you cool with that? Again, that'll be on the board for you, so you don't have to even memorize that. And now we go and affect the dimensions with what I call the drop arrow system. It's kind of annoying to do this drop arrow system, but it works. So they mentioned they did something. You see they did tripled. What does that mean to you as a number? What does tripled mean? 3. And I need to put an arrow underneath what dimension they affected. What dimension did they affect? Just the radius. So drop an arrow. I know it's weird, but drop an arrow right underneath that radius and put a 3. Do you see that they tripled the radius? But there's one more move. We have to take this number, I like you to circle it, and draw an arrow up to any exponent that you see. And that 3 has to get squared, because isn't the radius getting squared in this formula? And help me out, what is 3 squared? If you need to punch that in, that's fine. What's 3 squared? That's what I asked. What number is going to pop out of that system in the drop arrow? A 9. That is what's going to happen. If they did something to the height, we would drop an arrow under that as well, but they did not. So our answer is multiplied by 9. That's how the volume of a cylinder would change if the radius got tripled. Just like this. How did the area of this circle change if the radius got doubled? Isn't 2 the doubled number, but it's being squared, so it's really 4 times larger in that case. It's so weird because it's just hard to see without examples. Right? So let's try that again with the drop arrow system. How does the volume of a box? So let's start with that formula. Go to the yellow card and find that formula if you don't know. I got length times width times height. This is all the work shown you're doing on the test and everything. You're writing the formula and you're doing drop arrows. You drop an arrow underneath any dimension that got affected in the story. So it says the width is multiplied by 6. So I'm going to drop an arrow under W and put a 6. Does that make sense? And the height is doubled. So I'm going to drop an arrow under H and put a 2. Are we okay with that? Then you got to raise these guys to whatever power these letters are being raised to. They're all to the first power, so it's pretty silly. But isn't a 6 going to pop out in that situation? And a 2 is going to pop out of that situation right there. Does that kind of make sense? It's kind of weird at first. But then people ask a great question, what do you do with these two numbers? The same that you do with these letters. What was happening between the letters, addition or multiplication? Are they multiplying them together? So we multiplied these together. And how do you feel that the final answer is it got multiplied by 12? And that's exactly what happened back here with this guy. If we tripled the length and we doubled the height, didn't like a 3 pop out of one and a 2 popped out of the other, and we got 6 times as many calculators as we did before. So it's just kind of weird. But when they start changing to more advanced shapes, you got to really pay attention. So how does the, we're going to skip 9. Is that okay? Let's go to 10. What would happen to the surface area of what shape? Sphere. Go to the yellow card. Start with that formula. Surface area of a sphere. I believe he is 4 pi r squared. Does that sound cool? It says, what would happen if the radius was multiplied by 5? So go to that letter in the formula and drop an arrow. I'm the one that made this system up, so if you're like trying to Google the drop arrow system, that doesn't exist. I just made this stuff up. Just drop an arrow, and we have to take this 5 and raise it to any power that that letter is being raised to. So we'll do that, and what pops out of there? I understand where a 10 comes from, but it's not a 10. It's not 5 times 2, it's 5 squared. What number pops out of there? 25, right? We cool with that? Isn't that the only thing that happened as well, right? So then we can say multiplied by 25. Good questions that people have asked in the past. Can we say 25 times bigger? Answer on this one is yes, it would work. Sometimes these will get smaller, though. You know, so like I don't like to say bigger or smaller. I just like to say multiplied by, because if it got multiplied by 1/2 or 2/3, it's actually going to get smaller in that case. So multiplied by. Are we okay with that? Cool. Let's try another one. What would happen to the volume of a sphere if the radius was tripled? You and your table, let's try that. Or if you're at home, pause the video and start with a formula. It is a sphere, and we want volume. And again, hey, it happens to me too. I accidentally write 4/3 pi r squared all the time because there's so many times we do pi r squared, but it's actually pi r cubed. Are we cool with that? So let's drop an arrow. They say the radius was tripled, so ba-boom, and then we do that. And what number should pop out of the drop arrow system for this guy? 27. It's not 3 times 3, it's 3 to the third, right? So multiplied by 27. That's the basics of the drop arrow system. I need you to read number 12 because it's a test question. I need you to read number 12 and kind of get understanding. Then we'll talk about it after you've read it. After you've read that whole story, do this. What shape? What shape are we talking about here? Yeah, it's a ball, right? So we're doing sphere. What concept? Surface area or volume? Because we're going to wrap it with fabric, so we need the surface area of a sphere. See how this is rolling? It's just like, what shape? What concept? But then they got an evil little trick in there. What we call 4 pi r squared, right? What's the evil little trick? They don't tell us how the radius got affected. They tell us how the diameter got affected. So if the diameter is tripled, what does that do to the radius? Discuss what you think, and then we'll talk about it. Because the diameter got tripled. How does that affect the radius? My best advice ever is when you're unsure, if you can maybe like make a little sketch, I'm going to make a little sketch. I'm not going to do sphere, I'm just going to do circle, because I care about diameter to radius. So sketch with me, you'll probably thank me. Little circle, bigger circle. You don't even have to use your geometer, just a little sketch, right? Little sketch. And what I'm going to do is make up some numbers for a diameter. So I know this might not be obvious, but I'm going to make up a diameter of 2 for that little guy. I'm actually going to draw this much larger so you guys can actually see what the heck I'm trying to do here. All right, but I'm going to make this guy 2. You'll see why in a second. And then that one's supposed to be tripled. Right? So if the first one's 2, what's the second one got to be? 6. Are we cool with that? Well, why did I pick 2? Because I don't care about the diameter, I care about the radius, and my brain is kind of mathy. So if this has a diameter of 2, what's the radius? 1, right? I kind of forcing myself to have an easy number to deal with. Over here, this has got a diameter of 6. What's the radius? 3. Well, look, what happened? If you triple the diameter, what happened to the radius? It's also tripled. Are you cool with that? So like tripling a diameter does the same thing to a radius because the diameter is just a length, and a length is the first power guy, so it doesn't get squared. A lot of people think you need to do half of it because it's like, well, the radius is half as much as the diameter. It's a great thought, you know, but it's still just a length. So they tripled the radius. Cool. Throw that into the drop arrow system and see what happens. But I didn't know that without sketching a little picture. I wanted to see what happens. Like, okay, the radius still got tripled. And I'm all messed up in my area here. But they tripled the radius, so drop a 3 underneath there. So I'm dropping a 3. And what shoots out of there is not a 6, but 9. Cool. And that would be multiplied by 9. Or you could say 9 times as much because they were asking how much more fabric. I would accept 9 times as much in that case, you know. So multiplied by 9. But that's what I call the drop arrow system. I think it's way better than the first couple of problems where we had to find the volume of this one and then find the volume of the second one and then divide them. But there's an even faster way in certain situations. It doesn't work every time. This works every time. Right? The drop arrow system works every time. But down here, the super duper shortcut works one time when they mention if all of the dimensions are affected. Not just like a radius, not just like only the height or a length, but if all dimensions are affected, follow this lead. It says, how does the surface area change if all dimensions of a prism are doubled? Here's the cool thing. You don't even need formulas now, because the magic word, I want you to say it, is all. What was the magic word? Here's the super duper shortcut. Talk to me about the affected number. What are they doing? It's doubled in here, right? What are they doing? That number would be 2, right? Doubled, yes, means 2. Are we cool with that? So they are doubling all dimensions. That's what I call the affected value. Then, I've been training you all year for this. Do you know the label that you put on this concept? It's surface area. Do you put units, units squared, or units cubed on that bad boy? What is all areas labels? units squared, you will do that to this affected value. Do you see how I'm just going to square it, right? If it was volume, I would cube it, right? If it was just a length, I would go to the first power. But if all dimensions, this pops out a 4 in that case. It would be multiplied by 4. But that only works if all dimensions are affected. So let's check out number 14. It says, how does the volume of a cylinder change if all? So once they mention the word all, you could care less about even what shape it is. You just care about the concept of volume. Are you with me on that? What is the affected value? What are they doing to all the dimensions? 4. Are we cool with that? So affected value of 4. And the concept is volume. So what label does volume get? Units, units squared, or units cubed? Cubed. So you will cube the affected value. And that's a big one, right? You can punch that in. 4 times 4 times 4, or 4 cubed, multiplied by, did you get 64 back on that one? Cool. Try the last one of these. It's all about all. That was a weird way to say that. The magic word is all. And then you could do affected value raised to the power of the label. You can start passing them out. I got multiplied by 27. Does that sound okay? ACT questions right there. ACT is a timed test, so the faster you can get the right answer, the more benefits you have. So that's why I try to teach these. This super duper shortcut only works if they say all. Otherwise, use the drop arrow. No way do you have to show the first bit of work that we did. That was us crawling before. You don't have to find both volumes, and just do the drop arrow system or the super duper shortcut. Cool? Let's rock it, baby. Let us know if you have any questions. Have a good one.